All right, we're at 3 minutes past the hour. We're going to go ahead and get started. I want to welcome everyone to this Io-Tahoe Tuesday webinar, Bridging the Database Data Lake Gap. My name's Andrew Brust, and I am here with my guest, Scott Klein. Scott, can you hear us? Can we hear you? Scott, you with us?
Yeah, there we go. I can hear you. Can you hear me?
Yes, can hear you fine now.
Awesome.
And now that we can hear you, I'll go ahead and give a little intro. But I'm going to ask you to expand on it if you would. So we know you now as the CTO at Cloud and Devices. You and I met during your rather long tenure at Microsoft, where you were a global evangelist for what, at least to me, seemed like the entire data platform, at least in the cloud. And that included both conventional relational technologies as well as, what we might now group as data lake technologies, things like Hadoop and Spark and various NoSQL databases. But I also know you as somebody with a long history of experience with relational technologies like SQL Server. So
okay.
have I told everyone everything about you, or is there a little bit more you might add?
That about covers it. So I remember prior to joining Microsoft, I was one of the first 4 SQL Azure MVPs. I don't know if that is a good thing or a bad thing, but there was a time that was a category, and I was one of the very first 4. And then so long history of relational, and then enjoyed the movement into unstructured NoSQL type.
Great. So for those who don't know, SQL Azure is the cloud version of Microsoft's more than a quarter-century-old SQL Server relational database, the flagship database product. So you were one of the first MVPs for the cloud version, and then not long after that, they brought you in as a full-time employee, thus depleting the ranks of those MVPs down to 3, perhaps.
But that might be going back to the ranks, hopefully, here pretty soon to MVP.
All right. Fair enough. Well, it's good to be a charter member. I'll just introduce myself, too. I'm Andrew Brust. I also happen to have a pretty long history with Microsoft Data Technologies. That's how Scott and I came to be associated. But I cover the entirety of the big data and analytics world for ZDNet, not just Microsoft, although I certainly write on Microsoft more than occasionally. I'm also strategy advisor to Io-Tahoe, and as the slide says, my data-focused tech career started all the way back in 1985 with DB2. So, with DBase 2. So get out the walker and the cane, I guess, and let's talk about this whole notion of data warehouse technology with which we've been long familiar. That's certainly not a new thing. I guess going back to the 70s with Teradata, we've had data warehouse technology. And, more recently, we've had what we kind of bannered big data and Hadoop, and now we kind of banner it more under data lake. But we're still talking about the same kinds of technologies. We're talking about Hadoop. We're talking about Spark. We're talking about data stored in the file systems for those things, and also just data stored in cloud storage. More and more, that's becoming everyone's data lake. And I can tell you as a member of the tech press, writing about this stuff, that I know that the tech press tends to, the kindest thing I can say is we go where the puck is going and not necessarily where it is. So on the one hand, the analysts and the journalists are covering data lake technologies like that's the only thing that exists. And on the other hand, really, the market, that was a little subliminal showing of that slide, but I'll come back to it in a second. The market, on the other hand, is still largely living in the world, at least if measured by revenue, largely living in the world of the more conventional technologies. So what we want to talk about today is, let's kind of judge the relative pros and cons of each, and then let's see if this is about one replacing the other or if it's really about some kind of equilibrium and coexistence, and if so, how we can make that happen. And so here's the quote. This is from Merv Adrian at Gartner. So as soon as I have, disparaged the analyst community, here I have an analyst, a very famous analyst, bringing us back to reality. This is, by the way, a public quote that's on Twitter. The link to the tweet is down there on the bottom of the slide. So this is not paywall content that I'm quoting here. This is quite public. It's hilarious to read comments about how we live in a world, quote, a world dominated by Hadoop and Spark, end quote, when the collective revenue attributable to them is around 3% at best of the $35 billion database management system market. Interesting? Yes. Dominance? Not even close. So, the general theme there is the one I hinted at before. And this is such an issue in technology, and maybe you could shed some light on kind of how people at Microsoft handled it, Scott. But, there's always extreme pressure to be focused on really kind of where the next wave will be and not get stuck in the past. But when you get really enthusiastic about that, then you end up being a little bit maybe ahead of your time. And do you have a sense of kind of like if Merv Adrian's quote there is at all reflective of reality in terms of the way vendors are seeing the revenue, either in the cloud or overall? Let's start there.
Yeah, when you and I talked about this and wrote me that quote, I laughed a little bit because I think it absolutely is true. But you have to, let's take a step back and think about this from, if I'm a Microsoft, right, I've got this great product called SQL Server that does relational really, really, really well, right? You've worked with it. It does, it's, one of the top relational DB, in the market. But as a company, I'm like, okay, I can't, being at Microsoft, we're like, okay, we're not going to, how do I say this? We're not going to rest on our laurels, but we know, and we have to be, like you said, we have to be, somewhat forward-thinking because we can't let people pass us by. So we have to push the envelope a little bit, and I think that's what we're seeing is there's companies out there that are pushing the envelope, doing the research, and they throw something out there to see if it sticks a little bit, right? And they will sometimes go, yeah, okay, version 1, yeah, decent. We need to go back and maybe and revisit that a little bit. But it's a continuation of, how do we push the envelope and how do we be ahead of the game while looking at, yeah, I know that, again, there's things where and this is a true statement. There's or this is, I think you would agree with this. There's a lot of data out there that's just not relational anymore. How do we deal with that?
And
so
when we talk to customers, they say, well, actually, most of our data is still structured. So I think the reality is right now, at least, there's different profiles of customers. And I think maybe customers who are very kind of focused on, internet markets and quote-unquote web scale applications, they're probably seeing more of the unstructured stuff. The enterprises may be less, but, I tend to think that the first group there is kind of a leading indicator for what the second group will be seeing eventually. So even if,
right, and you and I talked about this, right? We throw something out there and it won't gain momentum for a few years. Right.
Still got to get it out there, though, right? Or else
you still got to get it out there. And this is what I was saying. They throw something out there to see if it sticks, and 9 times out of 10, it's somewhat close. But then they got to pull back and go, okay, test the waters.
Right.
But I think there's two things. I think they throw something out there and then they overhype, like you were saying, they overhype it because they want it. They've got to drive demand for it.
Sure.
So they overhype it.
What do you think about Hadoop and its rumored death? I'm a little sanguine about the whole notion of calling this stuff, data lake technology because I wrote about this for ZDNet when the Strata conference in New York ended this fall,
Yeah.
That used to be called Strata plus Hadoop World, and now it's just called Strata. And what's funny is, I as I said in my column, nobody wanted to say the H word, meaning Hadoop, but everybody was talking about data lakes. So I think to some extent that's because some of the data has moved to cloud storage, like blob storage on Azure or S3 on Amazon.
Yeah.
But do you see a slow, maybe quiet, maybe under promoted mainstreaming of Hadoop into the enterprise? Maybe people aren't, raving about it, but it feels like it's working its way into the woodwork, at least to me.
Slowly, slowly, and I think there's several reasons for that. As much as we'd like to think that that's the greatest thing, you and I are seeing the writing on the wall. It's taking far longer to get there, and I think you're seeing things like data lakes and other technologies that can do things just as good. And will there be convergence? I don't know. I don't think. I think there's several reasons why it's taking so long, and I think one of those is how is it one of the move to the cloud, right? How hard is it to set up Hadoop when I can go in the cloud and spin up a Hadoop cluster fairly easy? Right. But even at that, what's my learning curve, right?
Sure.
What's the how many people can really work with big data stuff? Big data technologies.
We're going to talk about a couple of technologies that make it easier to hit that data while staying in, the safe space of your relational database of choice and still get to that data. But there's also some storage economics involved. And
sure. Cloud is always much. Well, I shouldn't say always. Cloud is storage, data lake, much cheaper. And I think that there's a lot of that's what some of the trends that are pushing to the cloud.
Sure. Although I would say, just like people say never, I would probably say never say always. But certainly, I think maybe what's happening for customers is, cost aside, the idea that if I need more storage in the cloud, I just take it, and it doesn't become a whole procurement thing where I have to buy, more enterprise storage appliances. It's just, it's incremental to what I'm paying out of operating costs, and no capital costs. That ends up being kind of compelling. So I've got this title slide up here: "Reject the Zero Sum," and what we're alluding to here is this idea that it's probably not, maybe much to the contrary of what some of the vendors were saying for a while. The relational database isn't going away. In fact, there's been some renaissance of it because of the cloud. We'll talk about that too. But so part one is the relational database isn't going away. Part two is that doesn't mean that the data lake technologies are going away. I mean, it really looks like the more one thrives, the more there's room for the other. That these things have kind of different workloads, different purposes, or at least different sweet spots. You can definitely abuse one into servicing the workloads of the other, but probably the more sophisticated approach is to use, each for what they're good at. And we've got some ideas up here, and one of the things that's compelling about the data lake is that if you want to get some data in there, there's a lot less ceremony about it, right?
Yeah, it's much easier to get data in there, right?
But easier not just technologically, but also kind of in terms of procedure and even politics. It's a lot easier to get something loaded in a lake than it is to get tables and schema built for it in the warehouse, right? It's just a lower barrier to entry. Doesn't mean you can put anything there. Yeah. Doesn't mean you can put anything there, but that's why we're saying on the slide here, it's more experimental. And so it's a place where, maybe higher agility, even if there's less kind of, guide rails, no shoulder on the road, but you're still able to maybe get more done on impulse and do more analytics on stuff that you have not explored before than maybe you do on the warehouse side.
I think this opens up what you were alluding to. I think this opens up a whole spectrum of possibilities. We've been dealing with relational for many, many, many years. In fact, I saw on Twitter today there was a guy I know really well that was standing with Joe Selko. I think that's how you say his last name. You remember him? Kind of the godfather of relational.
I do.
And I was like, oh, man, that's a blast from the past, right? So we've been dealing with relational for a long time. And then here comes this technology, this big data technology, these data lakes, right? And I think there's still a learning curve, a area where I understand relational, and here's this great place where barrier to entry to put data that doesn't fit into my relational space. I can put data here and figure out how to process it later, right? And I think this is opening up. I think people are still trying to understand how do we use this data lake, and I think that's why things are taking so long, because what data do I put there, and how can I process that data? But I think people are starting to very quickly realize, like you say, they are very much complementary. They do not step on each other. Whether I use data lake as a landing place before it goes into my relational, or I just have a ton of data and I keep it there to process it later, whether it's with Hadoop or Spark or use SQL, things like that, it doesn't matter. I think there's very much, and I think this is where over the next, very quickly, 6, 12, 18, 24 months, we will see this massive growth of how these two play very well. And we see that with, and I don't know if you were going to get there, and hopefully I'm not going too fast, but you see things like SQL Server and including Polybase to be able to deal with stuff like that. Right?
Yeah, we definitely are going to get there. But now that the cat's out of the bag, maybe you can tell us a little bit about what Polybase is. And before you do, I just want to tell everyone who's listening in, despite the fact that you have a background with Microsoft and their technologies, what Polybase does is available on almost every single relational platform at this point.
Yeah.
In one flavor or another. But tell us about Polybase specifically.
Well, I think, and hopefully I apologize if I was jumping the gun a little bit, but
oh no,
there's this. I think there's this push, not just from Microsoft, like you mentioned, from all these other vendors, to say they realize that there's we're coming to this point where I'm dealing with data that doesn't fit into a relational database. But how do I make it easy to work with relational and non-relational together very easily, very quick, very easy, without having to go to this tool for this and another tool for that.
Right.
So what Polybase allows me to do is say, okay, let's talk just for SQL Server, allows me to use T-SQL to connect to Hadoop or blob storage or things like that, and write T-SQL against that data, so I don't have to learn new language or anything like that. Right within SQL Server, I can connect to, unstructured data and write T-SQL against it. Right, and there's
or maybe it is structured data, but it's stored in a CSV file in Hadoop's file system.
Oh, sure, yeah. Right. My point is that it doesn't have to be sitting in a relational database. It can be in a CSV file or in a whatever, and HDFS or blah, whatever, and I can use one tool to query, and work with both. And, so many vendors are supporting that.
Right. So I'll just point out T-SQL is the SQL dialect used with SQL Server. But if you're on DB2, there's something called Big SQL. If you're on Oracle, there's something called Big Data SQL. If you're on Vertica, there's something else. And actually, they all work on the same principle, where you use the create table command, but you say create external table. And then you reference a file in a storage location somewhere. And once you do that, it's almost like you've got a proxy to the data in that file that makes it look like it's a table in the database. And then you can use, your query language and your code the same way you would with physically local data. And oftentimes you can even join that data. And that's not necessarily the way to do a data lake, but it's a way. It's a valid way. And, whether you're using data lake technology to reach into a relational database or you're using relational data warehouse technology to reach into a data lake, it's it's all good. And there is, I think we're discovering there are multiple hierarchies in the data world. So one hierarchy is how hot or cold the data is, right? If you're going to be looking at really recent data, you're probably really recent data that almost everyone in the organization needs. That's probably going to be in the warehouse. If you're looking at older data, that may be stored on slower storage. You may want to put some of it in memory and some of it in SSD and some of it in spinning disk. That's one kind of hierarchy. But the other kind of hierarchy is that if it's data of consensus, it's probably in the warehouse. And if it's data that's a little bit more specialized or a little bit more experimental, really where you're more in an exploratory stage than in an operationalized stage of using that data, then it's probably going to be in the lake. So if we can get these things to work cooperatively, and by the way, I will telegraph now that the Io-Tahoe product itself can talk to both sides here and can even map the data flows between them. And I think we're going to need more and more technologies that kind of take it in stride, that most enterprise customers will eventually have both of these things. Right. And so Polybase is an absolutely, fair way to do it. So we have a few factors here in the pros and cons. And something I want to say about this slide is it's not that one column is pros and one column is cons and, maybe the other column is things in between. It's that there's kind of pros and cons under each of these categories. So on the economic side, you referenced this earlier, right? At least the object storage, the S3s and the Azure Blob storages of the world, those are cheaper, per terabyte or per whatever unit you want to keep data in than, in a relational database itself. And I think you said, and this is, I think, the fascinating thing about having you as a guest here, is that as an evangelist, you were interacting with both, the SQL Server team and I bet the analytics platform system team, but also the HD Insight team. HD Insight is Microsoft's flavor of Hadoop, and one of its many flavors actually of Spark. So you were talking to both of them, and I think you said you saw, maybe you could share that with us, you saw kind of what I might call chauvinism on each side. So maybe you could tell us what each side said in a moment of pride about their products.
Well, it's interesting. I'm trying to remember what I said, but
I don't want to put you on the spot either, and have you reveal any dirty laundry. But
I think there's. It was very interesting. When I started, there was SQL Server and SQL Server, and that was we're SQL Server, right? And then.
So that's sort of like you can wear any color shirt as long as it's white and any color tie as long as it's red?
Yeah,
so you
exactly, right.
You can use any database as long as it's SQL Server?
As long as it's SQL Server. And then, slowly it was, you had this other team over here kind of sprout up and go, hey, we're going to do, this is what I was alluding to earlier, right? Then, hey, we see this, or we're going to see this trend of data that doesn't fit into relational, so, let's spin up, start working with Hadoop, and there was a big movement around that. And these two didn't talk to each other very much, or if at all. Different buildings, different, right? And it was, don't cross that line.
Oh, the teams were in different buildings on campus, you're saying?
Different buildings on campus.
And so they didn't sit at the same table in the cafe together.
No, right, exactly. But what was interesting is that, over the last couple of years, that tune changed to the point where it's these guys sit at the they go through the cafe line and they're sharing each other's lunch.
Right.
Because I think there's you know, that happened fairly quickly. That change happened.
Okay, so I think what you're saying
quickly.
is there was almost a cultural segregation, but that kind of melted away over the period of, I'm going to guess, what, a year or two.
Over a quick period of time, because I think there was, you know, and there's still the, hey, I got to sell SQL Server, right? They're still relational, but you know, there was a quick change where, you know, how do we make these products so, you know, I think the purpose of this, you know, this webinar, how do we bridge that gap between, you know, the relational and the non-relational side, that, you know, SQL Server versus Data Lake.
Right. So, and I promised you we would mention Polybase explicitly. It's here on the slide. It's here twice, actually. I had it under economics and under SQL semantics. So economically, for data that hasn't, you know, been 100% onboarded and operationalized yet, it kind of makes sense to throw it into a cheaper storage layer and then use a technology like Big SQL in the IBM case, or Query Grid in the Teradata case, to bring that data into the analytics that you're doing on the warehouse. In addition to doing it, you know, in a pure play way in the data lake. But you're getting better object storage. I think when you and I spoke, you felt that the ETL performance, the data transformation, data integration work, that when there's really large volumes, that's often better executed on a Hadoop cluster, both better in terms of aggregate speed and also in terms of the cost of the compute. We've already established that the cost of the storage is better. And so that's on the economic side. Then on the SQL semantic side, let me just be clear about what that means. It means almost everyone in the enterprise doing data work knows SQL. And the notion that that was going to go away was absurd from the start, and there's pretty much consensus now that it was silly.
Right.
And as long as that's the case, that doesn't mean that you have to be a relational database adherent. You could say I'm totally in this world of kind of semi-structured, unstructured, you know, non-relational work, but SQL is still an important tool. So really,
you go back at that SQL semantics. Remember when the term NoSQL came out?
Yes.
And the initial thought of that NoSQL meant no relational, NoSQL. But people quickly realized, and I was a proponent of this when I would talk about, you know, big data. You know, I had a slide that said, you know, NoSQL means not only SQL. And there's this now understanding where, you combine the economics and the SQL semantics to understand that these two play very well together, and people are starting to understand how they play well together, right? Not just from the economics and the semantics piece, right? Storage is much cheaper, and I get the processing power. I don't have to throw things into, I get better performance by possibly, better economics by doing Hadoop, things like that. So I think there's this learning curve, but people are also the learning of how they play well together, if that makes sense.
It does. And I will say that the not only SQL, expansion of the acronym came in later as a bit of a backtrack. But most NoSQL databases have support actually for some flavor of SQL as a query language. So
absolutely,
really,
every single one almost.
Right. And so really what it's about is the fact that, these so-called NoSQL databases were good at saying, well, we won't be so harsh about schema. If you have schema change, we'll make that really easy.
Yeah.
If you have a kind of a database where, like, you have a product catalog where a lot of the attributes are common across products, but some of the attributes differ from product to product, we're going to be able to handle that. We're also going to be able to handle if you want to scale out and cluster this database or make it geographically distributed, we're going to make that almost brain dead simple, where, as long as you give us the IP addresses or the host names of each of the hosts in the cluster, you're almost done You know, and trying to do that same thing on SQL Server, by the way, or Oracle or DB2, not so easy, right? That's definitely, that's very much a senior premium skill set for anyone who can do that. You know, and it's also a lot of, you know, it's also a lot of getting called in the middle of the night kind of support. So there were breakthroughs there, and that's what's important about these new kind of innovative technologies is they're kind of revolutions against an entrenched standard that just makes some things hard and says, well, sorry, that's the way it is. So these guys made it easier. Go ahead.
I still think there's I think you're spot on. I think there's, you know, how there's that learning curve. I remember early on, and I shared this when you and I spoke, and hopefully it'll fit here. I remember very early on when, you know, Microsoft was talking, you know, NoSQL and, you know, and promoting NoSQL. And it just wasn't Microsoft either, because we saw this and others as well. But there was talking about the economics here and the SQL semantics. You know, we saw this trend where, you know, these, not just Microsoft, but Microsoft and these other vendors released these NoSQL data stores, and the storage for them was, you know, just from an economic standpoint, much, much cheaper, right? And we saw this for about a year. We saw this trend where people were moving their relational database out from the relational database into this non-relational store, you know, these non-relational stores, because the storage was just much cheaper.
Right.
And, you know, and all these vendors were screaming like, why are you doing that? And the answer was, but they quickly realized that was not, even though the economics was much, much, you know, better economics, it wasn't working.
There's hidden cost to that, of course, right?
Well, yeah, hidden cost, but you know,
it's a lower bill, but it's a higher cost in terms of skill sets and continuity and consistency.
Well, yeah, you know, you take, you know, I've got a database and you pick one. And DB2, Oracle, SQL Server, you know, it's got it's got the relational capabilities, primary keys, foreign keys, indexes. You know,
let us not forget MySQL and Postgres.
Yes, absolutely. Yes, all of them. You know, you take those out and you put that in a non-relational store that doesn't have those things. You quickly realize that the storage economics is better. The other costs of building that stuff, you know, those capabilities in. So, you know, there's pros. Again, there's talking about pros. There are pros and cons, but let's keep let's be real here. There's the economics and there's the SQL semantics, and we understand where where they fit into the ecosystem of.
Right.
Right.
Right. And then let's talk about the cloud. There's three things here. One, we've already kind of we've scoured it pretty well. That data lakes and cloud storage are almost becoming the same thing in some ways.
Yeah.
That in fact the cloud vendors, including Microsoft, are almost, you know, using this idea that our object storage layer is your data lake as a way to sell the whole cloud platform. Because, of course, the more data you store in one public cloud vendor's storage layer, the more business you're going to do over there. Because there is this notion of data gravity. So where the data is probably where you're going to bring the processing to. And so that's kind of a battle right now. But what's interesting also is that the warehouse, I kind of alluded to this before, the data warehouse is having a renaissance now. So as you know, on the Microsoft side, there's Azure SQL Data Warehouse, which is a cloud version of a data warehouse version of SQL Server. On the Amazon side, there's Redshift, and on the independent side, there is this there's Snowflake, and that company is hitting almost a unicorn status. They just closed on a round of financing in the how many figures would that be? 7, 8, 9 figures?
Oh yeah, it's you know, it wasn't a thing a year ago, and all of a sudden it's a thing.
Right, and you know why? It's because of the storage in the cloud. It used to be that the warehouse used enterprise storage and ran in an appliance, and if you ran out of space, it became a pretty frictional experience to expand that. the cloud data warehouses have separated compute and storage. Actually, Amazon hasn't, but Snowflake has and Microsoft has.
And Microsoft
so you can scale each one independently. Go ahead. I'm so excited about this that I keep cutting you off, and you're the guest.
Well, no, let's be real. I mean, the cloud and like data warehousing, this is now becoming. I remember when I was at when this was announced, right? And people were like, it's about doggone time, right? Mm-hmm. And the adoption just went through the roof, and it's a big thing. I think people really are finally starting to understand. I mean, very early on.
Adoption of what?
Azure SQL Data Warehouse, right?
Okay.
And the cloud in general, right? It took a while, but I think as people start to get the benefits of the cloud. And now they're going, you look at the economics and the semantics and the benefits the cloud provides. This is just doesn't matter. I mean, this is why Snowflake went from nobody to a thing almost overnight.
What's also interesting, of course, is that Microsoft's in Seattle. Snowflake is based in Silicon Valley, but they have a big and growing presence in Seattle.
Yeah, big office. Yep.
Google is in Mountain View, but a lot of their cloud stuff is in Seattle, and Amazon's in Seattle. So what's in the water over there?
Well, it's a secret, but
it's like you guys are data crazy.
Well, this is why we're having this discussion. This is. People get, they get their benefit. People understand the relational, data warehouse. They get it. But you start adding the economics and the cloud to that,
and then they really get it because it's something they're familiar with.
Get it.
And then they can take advantage of the revolution of the cloud without it having to be a skill set shift. And you're kind of making my point without knowing it, by the way, because the Azure Data Warehouse product is really just the cloud version of this thing that is now called APS and was once called Parallel Data Warehouse.
Yep.
And let's just say the number of customers for that product, that was an intimate elite group. There weren't tons and tons of customers. And now that it's in the cloud, it's the same product. But it's taken off by leaps and bounds, to use what I think was your term, and I think that drives home the point that, in a way, the popularity of a technology that actually dates from the 70s has only just been emancipated now because of the cloud. And so what you'll notice in everything we've talked about this slide, and we've spent a lot of time on it, but I'm glad, everything we've talked about here says that things are bullish for both the data lake and the data warehouse. There is no victor here. The winner's the customer because they can use both of these together. And the thing on the bottom right-hand side of the slide, I want to get to that too, but go ahead with the reaction. Go ahead.
Well, no, I think there's just driving home that point where it goes to if you look at the convergence of the relational data warehouse and relational to the data lake, this is just opening up a whole, it fits into every one of those silos you have, economics and the semantics and the cloud, where this is, it's not one or the other, and this shouldn't be one or the other. And if you look at this, it's like it makes sense it shouldn't be, and it's not one or the other, right? It just drives that point home.
And as the world, and if we're talking about hype being a little bit ahead of the reality, then here's the hype that's even further ahead. But there's a lot of talk about machine learning and artificial intelligence. There's little doubt in my mind that this will catch fire in a good way and become kind of the passion of every enterprise. We're not even close yet. But what's interesting is the data lake technologies are a fantastic place for acquiring the data, doing what's called feature engineering, which is just a fancy way of saying picking which attributes or columns are going to be most important to predicting an outcome, and then training the model and so forth. The data lake technologies are great for that. The cloud is great for doing the training work because the expensive and quickly changing GPU hardware is most efficiently used in the cloud, because you can provision a ton of it for a short period of time and then turn it off. And if the technology changes next year, you don't have to worry about rebuying, right? The cloud is great for that. And then here's the interesting thing coming round trip back to the relational database, and it is a SQL Server thing, by the way. The relational database can be a great place to take the model after it's been designed and trained and productionalize it and do scoring, i.e. predictions, against that model at scale. And of course, the newest version of SQL Server 2017, has functions built in not just to sort of do work in Python and R to get that data science-y stuff done, but there's even been a predict keyword added to T-SQL. So that just straight SQL queries, to go back to our point about SQL semantics, straight SQL queries can be used to run predictions against those models. So now we see a whole workflow, a whole kind of cooperative chain where you start in the lake, you do stuff in the cloud, you train stuff in the cloud, and then you bring it back to the relational database. And if that's not like a virtuous cycle, then honestly, I don't know what is. I mean,
it's kind of a circle of life thing.
Story. Yeah,
but it goes back to our comment earlier where we were talking about, how do we make it easy for you and I and other people to work with, bridging the gap, working with these technologies in a very easy manner, right? Where I don't have to go to this tool for this and that tool for that. We understand, here's these vendors now understanding where things are going, and they're a little ahead of their time. Right, it goes back to the Gardner quote. Right, we're going to push the envelope, but we're also going to make it so that it's easy for people to work with this. Right, if I need to do data lake or if I need to do data science, here's a single, almost a one-stop shop to do that.
Yep.
Right.
Yep. And I think. Go ahead. Sorry.
And I think those are the kind of thoughts, those are the kind of things that will help people push this further faster, if that makes sense, right?
It does. Gosh, I lost my train of thought for a second, but
sorry.
Yeah, no, that's okay. Well, it'll come back to me, but again, in general, just the notion that actually all this stuff is cooperative, I think, is super important. If we acknowledge what we were talking about before, where there's a hierarchy in data, which means there's going to be different technologies appropriate for different major levels in the hierarchy. There's also going to be sorry about that, but there's also just going to be a notion that again, different technologies will have their sweet spot for different parts of the analytic life cycle. It's all gonna coexist. And in terms of, I actually now remember what I was going to say. I co-chair a conference for developers. You know all about it because you've spoken at it. We encounter this issue all the time, which is that on the one hand, there's the stuff that's hot, and then on the other hand, especially with enterprise developers, there's the stuff that they're doing all day. And we want to avoid what gets disparagingly called conference-driven development, where you're picking technologies based on, what's new and hot. But ultimately, we have to serve both. We know that in order to stay marketable and relevant, developers need to learn the new stuff that they're not using yet, but will. And when they do, by the way, they're not going to have a lot of time to say, please send me for training. They're going to need to get busy with it fast. And we also need to keep them sharp and especially really efficient on the stuff that's been around for a while. And it's that kind of dual existence, that split personality, if you will, that I think is super important here. And I'm gonna skip ahead here because I think this is a great time to kind of bring in the fact that Io-Tahoe absolutely, subscribes to this philosophy, which is that ultimately enterprises are going to have lakes and relational databases. And by the way, our focus for a long time had been exclusively on the relational database side because that's where most customers are. But we know that the lakes are starting to become mainstream, and that ultimately, and especially with all of the regulations coming down the pike around data protection, that customers need to be able to master the data in both and also understand how the data is moving between the things. And that's not something you just do on the honor system by saying, okay, as I build it, I'm going to document it. It'd be good if everybody were that disciplined, but you're going to need tools that can analyze the data and actually determine those flows. Actually, in fact, using machine learning, that's exactly what Io-Tahoe does. So this whole notion that it's not either or, that there's going to be coexistence, that there's going to be diversity, that there's going to be variety, that there's going to be heterogeneity. I have no more synonyms left for that concept, but that has to be embraced, and Io-Tahoe definitely does that. So coming back down from the commercial sphere back into the conceptual one, it's important that, again, as much as we want developers and we want database professionals and data engineers to be both skilled in older things because that's occupying a big part of their day, and have readiness for the new stuff because it will occupy a growing part of their day, that having paradigms that are actually consistent across both worlds is really important. And that's the whole SQL semantics point. So we need the continuity of SQL and the relational structure of data, and there is a place for having that, and also having the formality that the warehouse has. There is a role for us to be strict, as long as we can also be more liberal and open-minded. So that's kind of the second point here, the ability to do things that are more ad hoc. We've been talking about ad hoc query since the late 80s, but it's really happening now with data lakes, right? The whole point, I guess, with a lake is you don't know the questions you want to ask. You're trying to figure out the questions. And maybe with warehouses and BI, it's more about answering the questions that you already formulated, but getting the answer.
Well, that was a question that I was going to ask. Was I think you are talking two things, right? There's the I don't know what questions to ask versus how do I know what questions to ask, right? There's the data warehouse. I know my data, so I just need to query and get my answers because I know what questions to ask. Versus the whole data lake, AI, machine learning, data science path where I don't know what questions to ask, and it was. And I told you, you and I spoke about this, a few years ago when we were, pushing Hadoop big, right? The HD Insight, Hadoop. We were like, okay, let's go and talk to some of our big customers and ISVs about, how do we help them? And they almost every single one said the same thing was, look, I know we're sitting on a lot of data. We just don't know how to get that information out. And I think that goes to what you were talking about is there's these two paths where I don't know what questions to ask. So how do we get, data science and this whole new, big data, data lake thing, we've talked a lot about, how we, these two bridge the gap, but how do we get people to understand how to use, how to use these technologies and services that we haven't been using for 20, 30 years? Right? How do we get them to understand how to bridge that gap, even when there's these services and technologies that do bridge that gap? And I think that's the challenge, right? Is we got all these data scientists. How do we get people to build up? We build all these smarts into our relational databases. How do we get people to start using them and understand how to use them?
Right. And so, and that's a good cut to everything on the right. And we're talking about SQL going in both directions here.
Yeah.
Technologies like Hive and Impala and Spark SQL are things that run on Hadoop and Spark, but use SQL to talk to the data. Things like Polybase and Big SQL are things that run on the warehouse side and reach into the data that's on the Hadoop cluster. And all of those things, the unfortunate part is it's easy to mix them up, you know?
Yep.
And that's by the way, there's another one here I didn't even mention, which is an open source database called Presto, which seems to increase and decline in popularity and relevance. The industry kind of can't make up its mind. But Presto is super interesting because it's not just SQL on Hadoop, it's actually SQL on pretty much anything. And there's another open source project, and boy, oh boy, it's going to escape me at the moment, but there are a couple of these that are using SQL as kind of a lingua franca to talk to anything, not just unstructured data, not just relational data, but even things in web services or in spreadsheets, et cetera. So that's going to be really useful. And then there's the AI point that I made earlier, which is that lakes help with doing the data science work of building the models, designing them, doing the feature engineering.
Yeah.
And we're seeing that relational databases can be a good place to take those models and, in effect, bring them in as if they're functions in, really stored procedures that we can just call and get a predicted number for. And that's important, too. So how is Microsoft kind of has almost dedicated itself to AI as one of their bigger bets. I mean, it's sort of cloud and AI, and I don't know what else. Certainly not mobile phones.
Yeah, we won't go there.
Oh, it's always important to get in a little dig at Windows Mobile, I suppose. Just as a cheap shot. But
quick duck. That's good. Look, you said this earlier. Microsoft is still betting big on relational. But that doesn't mean that, data lake, big data, and AI isn't important. It's how do all these play together? How can we use these to, make a better world? Things like that, right? One's not going away. Relational is not going away. And, even one of the GPM of relational said that SQL Server 2017 is one of probably the most important releases of SQL Server in over a decade, right? Mm-hmm. Just all the stuff, and you see that with inclusion of, like you said, R and Python, and right, that stuff's not going away. But we also understand
for folks on the webinar who are not, necessarily familiar with all these names, those are probably the two most important programming languages in data science and AI. Right, and they're now integrated into the relational database, as is again that ability to use a model and do a prediction against it.
Yeah.
And so we see like the database is almost like a collection point for all of these new technologies. Right now, you've got functions that can reach out to Hadoop clusters. There's also features in SQL Server now to do NoSQL style things. There's graph processing and JSON processing. Those used to be the exclusive domain of graph databases and document databases, but they're in SQL Server now too. And again, it's not just SQL Server. This is happening across the industry. So the database, the relational database, really ends up being like the integration point for an awful lot of tech, like the place where, again, a lot of that stuff gets put into production.
Yep, but I think there goes, now how do we use all of these data lakes? How do we use all of these together, right? In a nice cohesive way. That's
give us step 1, 2, and 3. Bring them together.
Yeah, and that's what they're
no
doing,
pressure,
right? That is, so it's not an either or. It's a nice cohesive set of, and a lot of vendors are doing this, right? So I think this is where we see again vendors pushing the envelope, saying this is going to be hot, and then figuring out, hey, we threw this against the wall. It's sort of stuck, but let's figure out how do we make it stick, down the road. So I think that's what these guys got to do is be forward thinking and then put something out there and see if it sticks, and this is why we see in SQL Server 2017 the inclusion of R and Python in these languages, because this is where, this is what their understanding is. I think it's great to see that.
I think it's incumbent on the vendors, though, to do more to simplify this stuff. I mean, if you look at the data lake stack, you've got Spark, you've got Hadoop, you've got things like, Pig and Kafka for streaming data, TensorFlow for AI. It's all these little open source individual components, and I think what really needs to happen is those need to be brought together, number one, and number two, kind of pushed down so that they're the engine, and we can have some easier to use development system on top. And I would say Polybase and the technologies like it, Big SQL and Query Grid, et cetera, et al., that is the right direction, but it's like just the beginning of what we really need. We really need something.
Absolutely agree, yep. Right? But I think there's some danger there, right? Because how do we go, hey, we're going to take all of this into one massive, right? How do you bring Spark together with relational? How do you bring, and maybe it'll happen, and that's not our job to figure that out now. But
well, that's why the vendors make the big bucks. They need to do that. And again, that's why Io-Tahoe is doing it in terms of smart data discovery, relationship discovery, data flow, sensitive data discovery, and redundant data discovery. That's why we got Cool Vendor in April of last year. So you like how I just kind of harvested
your segue.
I swept you right into the commercial message, but of course, we have to pay the bills. So
I said that just so you could just for that awesome segue, you can segue right into that.
Yeah, and I appreciate you being my straight man there, and I appreciate you in general being our guest. I think this was a really good discussion, and I think we got to some important conclusions. Well, one we kind of really telegraphed from the beginning, which is that it's not either or, it's both. And number two, there are some unifying factors, one of which is SQL, another of which is the growing importance of machine learning and AI. That's probably what's going to make it more than philosophically important, but really practically important that these things need to be used in tandem and in an integrated manner. So I want to thank you for being our guest.
Thanks for having me. This was fun. I always enjoy talking like this.
Awesome.
Great discussion.
And you've had me as your guest on shows, so it's only fair that I reciprocate.
That's right. We need to do that again too. Yep.
I want to thank our audience as well. We're right at the top of the hour, and tune in 2 weeks from now when we're going to be talking about the General Data Protection Regulation of the European Union, which is coming in force at the end of May. Anyway, thanks everyone, and have a good day, evening, or morning, depending on your time zone. Take care.